All right, guys. So I am going to be going over the Unit 5 study guide. I'm only going to go over questions 1 through 8 because that is what you are going to be tested on tomorrow. The rest you will eventually get tested on. It will just be a review, okay? Now, with question number 1, it is asking me to identify the type of association for the data and create your own graph on the separate sheet of paper. So you are going to have to use a graph on the test, and we're going to go ahead and create one really quickly. Okay, now when we are creating our graph, we need to make sure that we are labeling our x and our y axis appropriately. Meaning, if I look at this table right now, I have to figure out, hey, which one's going to be my x and which one is going to be labeled as my y. Okay, we always have to remember that x is time, or that when we are looking at a table, x is always on the left side and y is on the right side. So looking at our time, or our left side of this table, which is your x-axis, it is going to be years since 1999. And then our y value is going to be admissions, which is dollars. Okay. And now I have to go ahead and number. So I have 0, 1, 2, 3, 4. And I'm going to try my best because this is, I don't have my grids. So we are trying our best. Okay, so now I'm going to go ahead. Remember, when we have our table, these are also full of ordered pairs. So I have 0 and $5.08. $1 and $5.39, and so on. Okay, so I'm going to go to my first order pair right here and plot it on my graph. So I have 0, I'm not going anywhere on the x-axis, and I'm staying along the y-axis, and I'm going to plot my point as close as I can to 5, just because we only have 8 cents. Okay, go to your 1, which is 1 year since 1999, on the x-axis, and then I'm going up to $5.39, and that is going to be, once again, closer to that 5, just because if I do it straight in the middle, that means I have $5.50. Okay, going to 2, a little bit closer to the 6. 3, I have $5.81. And for year 4 after 1999, it is going to be above that 6. Okay, so now I see that I have my points plotted, and if I were to draw a best line of fit starting from my y-intercept, okay, I am going to see what type of association it has, okay, which when we are talking about association, we're talking about linear, nonlinear, positive, and negative, okay? Since my line in this graph is increasing, and remember, when we are talking about linear with scatter plots, my points don't necessarily have to be, all of them have to be on that line. They just have to be close enough, or some of them on there, okay? So it just has to create some type of line. Doesn't necessarily mean that all of my points are going to be on that line. Now, if I look at this, my line, my best line of fit is increasing, and it is going to be linear. So that leaves me with option A, or that very first option, okay? All right, moving on to number 2. It's determine if the scatter plot is a better representation of cluster or an outlier. So when we are talking about cluster, we want to make sure that we're looking at groups. Okay, so cluster, we're really looking at groups or grouping of data, groups of data. And we are talking about an outlier. Okay, it is a data point that is out of all the other data. So it kind of looks just like a random point outside of, if it's a linear line, of all the other data. So a data point, if this writes, a data point outside of the others, we'll say. Okay, now if I look at this, they're little blobs of data points all clustered together or in groupings, okay? So this one is going to be cluster, okay? And then moving on to the next one, which is number 3. This one, this is what I'm talking about. We can have our best line of fit here, But because we still have 1 point kind of randomly outside, okay, we want to make sure that we can see that data point, which is clear here, and that's why this is considered an outlier, because we have one data point that is not with the others. It is all the way in a random spot, okay? So this is called an outlier. The way that I kind of think about it, if you get cluster and outlier confused, is we have a line right here and it's outside of that line, okay? Now, it's not always going to be a line, but we're talking about a data point that is outside of the fitting, okay? Moving on to number 4, we have using the graph below, order the sentence from 1 to 3 to match the graph, okay? So we are trying to match the graph from the very start, which is at the origin, and order the sentences that are given to us. So reading the sentences, it says Mary returned to her house, Mary left her house to go to the mall, and Mary stayed at the mall to shop. We want to make sure we are looking at what time, or our x, and what our y axis are representing. So we are really looking at time and the distance from home. So we are organizing, and since we are starting from home right here, her distance is increasing away from home. Okay, if we look at the sentences that are given to us, it says Mary returned to her house, Mary left her house to go to the mall, and Mary stayed at the mall to shop. As she is leaving her house, okay, anytime you leave your house, your distance from your house is increasing because you're getting further and further away. So that is our first step to, or our first sentence in our qualitative graph, okay? Mary left her house to go to the mall, her distance is increasing, okay? Now the second part to our qualitative graph is this horizontal line, okay? Whenever we see a horizontal line on our graph, that means that we're staying at a steady position, a steady pace, okay, where our distance or our y values are not increasing or decreasing. It is just staying the same. Now, when you get to your destination, let's say you go to a restaurant, you go to a mall, for this instance, you are staying in that same location. You're not leaving, you're not, unless you are ready to go home or go to a different location, you are staying at that same location. Therefore, is your distance from the home increasing or decreasing or staying the same? Okay, because she is staying at the mall to shop for a bit, her distance from her house is staying the same. Okay, so that is Mary stayed at the mall to shop. And then when she's ready to go home, her distance from her house is decreasing because she's getting closer and closer to her house. So this one is Mary returned to her house. Okay. All right, number 5. So this one says describe a qualitative graph to represent placing a tray of water in the freezer to make ice cubes. Label the independent variable in the time and the dependent variable as temperature, okay? The most important thing to remember is that we have independent variables and we have dependent variables, okay? This is going to let us know, hey, your x-axis or your x values or whatever it represents, and then y is going to be your dependent, okay? So your independent is x values, or x-axis, and your dependent is your y values or your x-axis, or your y-axis, sorry. Now, looking at what independent represents, independent variable time, okay? So that means that my x-axis is going to be time. And then looking at what my dependent variable represents, it says dependent variable as temperature. So my y-axis is going to be temperature. Okay, now it says describe the qualitative graph. Since we are describing it, we're basically just saying what the actual scenario is doing to that temperature, since we are talking about temperature. So it says represent placing a tray of water in the freezer to make ice cubes, okay? Now, the type of options that you have here, it's like starting at 0 degrees or starting above 0 degrees. When we are looking at water, we get it from like the faucet, we get it from water bottle, okay? If your water is at 0 degrees, that means at that point it's super cold. I mean, it's not room temperature water, okay? So if it's starting at 0 degrees, which is your origin, your water's not gonna be at 0 degrees, okay? So starting above, because your room temperature water is going to be above 0 degrees, okay, we have to figure out, is our temperature increasing or decreasing when we put it into the into the freezer, okay? When you put room temperature water in the freezer and it's trying to get frozen, your temperature decreases as time increases, because as the time goes by, your the temperature is getting lower of that water, okay? Now, after freezing, when it's done being frozen, your temperature will stay the same just because it's frozen. It can't go any colder than being frozen, okay? So after freezing, temperature does stay the same. Okay, now when I draw that into a qualitative graph, okay, remember we are starting above 0 degrees, so I'm not going to start at the origin, I'm going to start a little bit above, okay? So let's say I start right around here. The temperature is decreasing as time goes by, and then after freezing, it will stay consistent at a temperature, so it would go, remember, staying consistent, staying the same, is just going to be a horizontal line after that, okay? All right, moving on to the next one, number 6. So we have our two-way table here. It says there are 195 students. Hold on, sorry. I don't know why this is showing up. Okay, there are 195 male students and 126 female students in 8th grade at a middle school. A survey showed that 110 males and 84 females ride the bus. Complete the table below. Now, when we are looking at this table, we want to make sure that we are looking at the categories correctly, because we don't want to fill in information that is not correct within the categories, okay? So looking at this, we have a bus, we have not bus, and we also have a total, which is the total amount of either males, females, depending on what way you are looking at it, okay? Now, when we're looking at this total right here, so that total, okay, we are looking at the total of males because we're going through our rows. We have males total and females total. So first thing that I'm going to do is I'm going to look at that first sentence. It says 195 male students and 126 female students in the 8th grade at middle school. So I have a total of 195 male, so I have male total, and I have 26 female total in that middle school for 8th grade. So 126, okay? Now, this box right here, this is a total amount of students that I have. So all I have to do now is add 195 plus that 126, which gives me 321. Okay. Now, they also give me another piece of information, which a survey showed that 110 males and 84 females ride the bus. Okay, this is telling me that 110 males and 84 females ride the bus. So I'm not going to look at the column where it says not bus, I'm going to look at the column that says bus. Okay, and once again, I'm making sure that it fits into the category. So the first box right here, it has males and bus. So I'm going to plug in that 110. And then for females, I have female and bus and plug in my 84. Okay. Now, if I had to figure out how many people rode the bus in total, I would just add 110 plus 84, which gives me 194. Okay. And then from there, I have a whole nother column figured out, okay? Now, I still don't have the information for not bus, but they did not give me that in the story problem either, so I have to figure that out with my total amount that I have and however many people I have riding the bus. That is just the leftover people. So in order to find out how much I have left over, I am using my subtraction, okay? I'm subtracting the total amount of male students with the total amount that ride the bus. So 195 minus 110 gives me that 85. And then once again, I'm doing the same thing. 126 minus 84 is 42. Okay. And if I have to figure out the total, remember this row right here is total of how many people don't ride the bus, I'm adding 85 plus that 42, which gives me 127. Okay. Moving on. So this one says select which equation will represent the line of best fit. We always have to make sure we are looking at what our x values represent and what our y values represent, label and number wise as well, because if we were to use rise over run to find our slope, a lot of us tend to think that each unit or each square represents 1, okay? According to this graph, it doesn't. It either represents 100 or it represents 10, depending on the x and the y axis. So we need to make sure we are looking at those numbers, okay? Now, in order to find out what my slope and my y-intercept is, I'm going to draw my best line of fit first. So starting from the point at the bottom, I'm going to just draw a line that best fits this equation. And I'm going to draw that again. Okay, so looking at what the kind of the direction of all of my data points are starting off, I like to start at my y-intercept because it's a little bit easier to identify. And if I look at my y-axis, it's starting at 0, therefore I don't have a y-intercept. Our value for the y-intercept is just 0, okay? Now, doing my slope, I'm going to look at I'm going to use rise over run, and I'm going to use this point because it's the closest I can get to the line, and this point right here. Okay, now using rise over run, okay, I'm going to rise to get to the same level of my second point, and when I rise and get to the same level as this point right here, I have risen 100 over my run, and that means how many times am I going to run or go over to get to the actual point. Okay, so the distance from one point to another point. And since I only went over one box and my x values are going by 10, that means I ran 10. Okay, so when I go ahead and divide them to simplify it, I get that my slope is 10. All right. So then I go ahead, keep going at my options. When I write y is equal to mx plus b to write it into my equation, we don't have a y-intercept value. It is just 0. So at the end of the day, it's just going to be y is equal to mx. And I plug in my slope, which is represented by m, which is y is equal to 10x. And looking at my options, it is going to be A. All right, and our very last one, it says the independent variable is time expressed in hours, and the dependent variable is the score on the final examination. Okay, so I'm going to write an equation for the line for the best fit, describe the slope, and describe the y-intercept, and predict the final exam for 6 hours of study. Okay, so looking at my graph, I need to find slope, and I need to find my y-intercept. Okay. Looking at my y-intercept, once again, starting at the y-axis, it is close enough to that 50. So I'm going to use 50 as my y-intercept. And now I'm going to use rise over run. So I'm going to look at my graph, okay? And with finding the equation for the line, I'm once again going to use this point and find another place where it crosses the grid, and there it is, okay? So I am going to go ahead, I'm going to rise to the same level as my next point. Okay, rising there, and once again, you have to make sure you're looking at the how much it's going by on my y value. So I rose 10 because from 50 to 60, that's a difference of 10. And then we are running 2 units, okay? Now, if I look at my x values, those are actually going by 1, so I can go ahead and use 2 on that. Okay, when I simplify that, that gives me a slope of 5. Okay, so I have a slope of 5, and I have the y-intercept that is equal to 50. So plugging that into my slope-intercept form for the equation, I have y is equal to 5x plus 50. Okay, and on the study guide, you're going to see that they have a box for your slope, which is right here, 5, and a box for your y-intercept, which is 50. Okay, all right, moving down. Describe what the slope represents. So when I'm describing what the slope represents, it's almost like describing your rate of change, because remember, rate of change and slope is the same thing. When we're describing this, we want to make sure we include our x and our y-axis, because that is what we're looking at how much it changes within the X and Y, okay? So describing the slope, what it represents, if I look at that line, if I look closely, every time my hours increase, my score on that final exam is going to increase. So explaining that, okay, my line is increasing consistently, okay? So that means my hours and my score is increasing both. So putting that into a sentence to explain it, it's how much my exam score or the exam score increases as the time of studying increases as well. Okay, and I didn't fit increase, but this is increase, okay? And then it says describe your y-intercept. Remember, your y-intercept is the initial start, or where it starts on the graph. So your initial start, if I look at my y values, your y value represents the score on the final exam. So that means if I did not spend any hours, because 0, it's on the y-axis, I am going to get whatever I have on the graph for my final exam score. So to describe that, it is going to be the anticipated score with no studying. Okay. All right. And now it says predict the final score, or the score of the final exam if a student spends 6 hours studying. So we are looking at how much they will end up scoring on that test if they spend 6 hours studying, okay? So I'm going to use that representation of the equation that we found at the beginning, which is y is equal to 5x plus 50. And I have to figure out where am I going to plug in this 6. If I go back to my graph, if I look at 6 hours, okay, out of x and y, the only one that represents time is my x, or my x-axis. So I'm going to plug that 6 hours into my x. So I have y is equal to 5 times 6 plus 50, okay? And remember, x is always time. No matter what, x is always time. So 5 times 6 is going to equal 30. Bring down my plus 50, and when I add both of these, it's going to give me 80. Okay, so that means after 6 hours of studying, I have scored an 80% on the test. All right, so this is a quick review over tomorrow's test. If you still have questions, make sure you ask us, you email us, so we can get you started. Please don't forget about your reviews on Friday as well. Okay, have a good